Hello, welcome to another video. Gonna continue on with the microcorruption capture flag from quite a while ago. The idea is you have a bunch of points on a map, as you can see. The yellow crosses we can do. The red ones are locked for now. The idea is we basically have a lock that is connected to a door, and we get connected to a debugger, and we can kind of see what the code does. We can see what the memory has. There's also like kind of no, where's this one? You can also kind of see I've lost the train of thought going to the wrong page. What I'll do is kind of just jump into Johannesburg. You can also have locks that connect to like hardware security modules and stuff, and there's some stuff I can open up when we need it, saying what interrupts are needed. Potentially we'll need it soon. So this text is mostly just boilerplate. It kind of says what happens, and usually at the end there's like a little thing saying what they've done. So maybe they've done some, tried to catch up with the buffer override, which I think we had control of. So what we can do is we can see in main, so in main we're calling a thing, and when we return, that will add something to the stack. So say if I break there and continue. So when we get here, we can, sorry, my standing desk mat, which is this. I could stand. I'm not sure I've ever stood in a video, but yeah, it sometimes gets in the way of the wheels of the chair. But that's better now. So what happens here is we have a stack pointer, and if we step into this, what will happen is the 3C44 got added to the stack. And if we scroll up and see where main is, 3C, no, what happened there? 3C44 is in one of the Indians. I'm not too sure. I guess I'm like dyslexic for the Indians, but I can look it up and work out which one it is and then stick with that. So. But what's happening here is it's 443C, and then 443C is the next instruction. So that one here, which what we want to do is kind of overwrite this area of the stack. So if we scroll down and see what this does, we get a serial number, and we putting it into 2400. And this said that it tests the length. Doesn't seem like it does. I don't know. What will happen? So we put it in 240. So we can kind of see where things end up. So I kind of want to maybe break on that point. And if we continue, I've done something to my thumb. I think I've got one of those annoying thumb bruises. So here I kind of want to actually see my progress. Is that what I do? No, I want my data. Yeah, I want one of these really long ones just to kind of see, maybe I can get away with something like that. I just want this so I can kind of see what's happening in the memory when I do it. Which this has some other things, but yeah, we when we see the 454cc, we can work out what's happening. This potentially will just solve it, who knows. Right, so if we continue from there, we'll see at 24 there, we have overrun like all of this. So what happens now? We are trying to do a string copy. Yeah, basically these two things. So this is going to basically move our stuff to where the stack pointer is. Doesn't seem like it's protecting against that thing. So if we say next, keyboard shift over slightly, that has basically put all our stuff here. So what I want to do is actually just go to red. Potentially I've just finished it. So if we go here, oh yeah, something, was there like another thing? So here we put in this sort of data here. If we continue, we should end up somewhere. So we do like a kind of, I see. So what happens like after we do the test? So if the test is wrong, then we go to +44, which I guess I want to just maybe pause there and just do a step. And so we're here. All right, maybe I'll clean up some of these things. Right, so what do we do here? We are going to say the password's not right, so we can say that. And now we're doing like a thing where it's checking something in the stack. So I guess this is checking that a value was in a certain place beforehand. So what I might do is reset it again and continue. We can shove our stuff in here. That's already done the string copy. What I want to do is maybe before there. Because this one is going to be too long. So at some point it's checking for 1C. So there is a value 1C here. And we can see how far it is. So it's each one of these is 1 byte. So 1, 2, 3, 4, 5, 6, 7, 8, 10, 12, 14, 16, 17. Well, yeah, so the 18th byte we want to change. So let's see what we've got. And we can kind of see it's like 16, 17, 18. Yeah. 17th byte. Yeah. So, gosh. We can see it's just one row down from where we are in the hex dump. That means it's 16 because that's just how the numbers add up. And we can confirm this by saying that the tens digit in the hex, or aka base 16, is gone up by 1. Well, it's gone from E to F, which means it's gone up by 1. and next it will flow over and do 100. So this means the byte directly after this, so the 4C55, we want to be 1C, was it 1C? And I think that's what we want. So we can have a copy of that, and maybe we can reset this and try it with our new. So what happens after this copy? We still have that same thing there, perfect, and then some other stuff. Now what we want to do is see kind of where it ends up. Right, I don't really care about that breakpoint anymore. Potentially not even that as well. Just kind of see where I end up here. So, well, I guess to confirm it, yeah, so it goes to the red now. And where are we pointing at? Just after that, which I think I've overridden to nothing. Ooh, interesting. I thought I overrode it to that. Maybe it's not letting me overwrite everything. Was it because it's got an OO? Yes, it is. It does a string copy, which, how do I get around this? So, yeah, maybe I'll kind of demonstrate with a thing. I don't know. Well, maybe I can just look at the manual of a string copy. And so what this is going to do is it's going to basically stop at, it probably doesn't even say it explicitly. It will stop at when it hits a null byte, the terminating null byte. Oh gosh, I hope. I feel like I need to sneeze, but I haven't yet. Yeah, so these bytes here were not overwritten. And it is interesting. So what was the thing we were comparing? We were just comparing the byte. So we can just change this to something else. I don't know. So if we do a reset again, and then do the, we still there. So now we have got to the ret, and we've overridden this to 0101, which potentially is not the right thing anymore. So what we want to jump to is, well, it had a function for unlocked or didn't it? So we could probably just jump to there. If I can find it. Well, there it is there. Cool. It won't break there. So, I didn't really want to. That's annoying. I've overrun my copy buffer, but I don't really have a clipboard history set up, which kind of means that I need to like get all the stuff again. basically undo all the work that I wanted. Right, so here we needed the 11th byte. One. I could do this a little better. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Is that where it wanted it? I thought it was like a whole row down. Yeah, so it will be a whole row down when we do it. I think. So we have up here, there. So we want the 4C5 to be AA, and then what was it, 1C? We just need that 1C to be right, and then the this can be the return address, right? 443C was where we called from. 443C. So that one we can overwrite with the 4446, but it'll be written as well, we can 4644, and this starter in between just has to be anything. It's like expecting a return address, and then we need a 7F, which is the code that you use to unlock the thing. No, we don't really need to do that because we're going to the thing. So we could probably get away with that. And if we continue from there, we're now at this continue. Now at this ret, I mean. And the return address is 4446. So when we step from here, we should be in unlock door, and that will unlock the door for us. So if we run that again with solve, and so we'll try and make it a shorter message, and we can do that. What I want to do is kind of how do we do this? Or we can do like 116, I think. Do echo $I, lowercase I, done, and yeah, so that's the thing. And what I want to do is do a printf and maybe print it as hex, but print it twice, and we can do $I. What does that do? That gives us a bunch of things. And then that's 10, yeah, because we're printing 16, yeah. So how long was our test string? It was that long. Not lines, characters. It was 49 characters long, so it's really 48 is what we want. 48 divided by 2 is 24, so I guess we should go to 24. And that will print us a big long string, and it will kind of make it easier to see where the 16th byte is. So if we say do that, and we could, what I want to do is maybe do this and do that, and we can see where the thing that we need to change was. So we need the 1C, and that was what Johannesburg. It was testing 0x11. I'm not sure I made it what I want. Oh no, I see what's happened. I was looking at the command. I guess it would be nice if that was in a different color. I might change that at some point. But yeah, what I want to do is compare these two to see. All right, this is where I changed it, and it's no, not there. The 1C. So the 1C is 11 up here. Like 1-1. So I guess all of it kind of gets a bit weird after 11. So I think I want to do 2x and just do it once. Maybe is it like 0 to x? And then that might be a bit clearer. It's still off by 1, but that's because we haven't got 0 in the mix. And we could have 0, but it would be better if we start from that. But yeah, so that's I'm showing where the 11th bit is there. So maybe I'll copy this string here. How do we do this? I kind of want to do. Give me my command back. I kind of want to do 2-1, and beforehand I'll just do a printf, ff, and then we can get all of that. And because I forgot to pipe it, I'll do that instead. Cool. So now I've kind of got a string that will help debug like where things are. I don't know. It could be helpful, might not. But yeah, here we can see the what was it? Yeah, 11th in the stack, and we can kind of see what the 11th in the stack is, and it is just 11 in hex. But yeah, anyway, I've solved this one. So let's head over to Santa Cruz. So a bunch of stuff that you don't really need. Right, they've done more stuff to make sure you can't have too long a passwords. I reckon we can still have too long a password. So I kind of want to, right, so we put in some like stack magic. Oh wait, what's that doing? That's like subtracting a bunch off the stack pointer. We in that order. All right, and then in login we. I mean, I assume that does the same. It looked like it called the thing. Here we do this, and we do like some different stuff around here. So I think I might want to kind of inspect that. And we also do some stuff here because R4 is the stack pointer, and we do some things. Then we like do that to the stack pointer. So this is potentially a little trickier. Yeah, I don't know. Let's see where we end up. So here we have stack pointer of 4, or like at this point here. Perfect. So when we do this, we subtract a bunch off. It's a negative number because it's got more than 8 in the the last digit is more than 8 in the first nibble of the whole thing. So I did a thing. I just pushed enter, but that's all right. So in here, what happens? We are going to change some things. So R4 and R11, I didn't think had anything useful, but it's pushing basically 2 zeros into the stack, so it's kind of moved the stack up. I guess that's to yeah, I guess that's to kind of do some things. So here we add 4 to this, and then we are subtracting some stuff off stack pointer. Maybe that's like to get back to where it was. PCs there. It's like in the middle of thing. We've kind of lost where our stack pointer is looking for 3AO. Yeah, it's like in this chunk of zeros. This shouldn't have changed anything. This should put an 8 somewhere. So that put an 8. Did that make our thing sharp? It put an 8. Oh, this font is because it's got the dot. So sometimes having the dot is useful to differentiate between a 0 and a capital O. So, for example, in this font, in the browser font for the input, the digit O is just thinner than the capital O, but that's the only differentiation. But for example, in my shell, I have the gosh, where is it? I have the thing in the middle, and I wonder. So my 8 has like a lot more white space, I guess. I don't know. I've never really noticed it before, but I just found it. It's also smaller, but yeah, like I can see that 8 clear as day. I mean, I wrote it in, but then looking here, I'd have to kind of, oh yeah, there's an 8, but then are there any other 8s? Interesting. And if you increase the font on this, it gets real jarring because like every move it does, it wants to resize up. I think this resize it might be alright. Anyhow, enough rambling on about fonts. See what is next. So we put that 8 there. And we should put a 10 at, see, like here because it's red, I don't know. That 8's different to that 8. See, that has like a real fat bottom and thin top. I don't know. Maybe I'm just like rambling about fonts too much. Alright, so we should put the 10 a little bit, yeah, so it gets like kind of jarring like that. Is this like, and where we put the 10, just the next one over. So might be useful to note that this was what that was. But what do I have there? I kind of want to keep some notes, maybe. And maybe I'll just have that test string. But then I want maybe this layer. Yeah. So notes won't show most of the time, but they will sometimes. And then we can kind of say what this was. And then yeah, I think it would. Didn't say it, but yeah, you got that back. Cool. So we do that. We get this, and where do we put it? We put it like at quite a low thing, or does get SN now actually care about? So we've got a username and a password. This is different actually. So I guess if we put in our little test string here, and maybe I want this to be 01 for, well, for user, I don't know, I'll have 88. Just some random thing so I can see, oh, this starts with an 88, it must be that username. Maybe just rambling. It prints it out. Gosh, I reckon there could be some cross-site scripting potential here. It just gives me raw bytes. It's just giving me raw bytes. It is wrapped up in a string, but yeah, potentially not. Right, and then FF can be the password of the whole thing. So I kind of want to see where in memory things have ended up. Have we got anything at all? I would have thought that. Right, so we'll get here. So at this point here, we should have like some things at some point. Oh, and I did like a string copy from that. So that's from the stack pointer. So the stack pointer, does that have some of my data? Yeah, so it's got 88 there. Perfect. But then like at the end we do some stuff. Right, so this does like some things. Maybe I want to stop there. Gosh, and there. And like maybe there and there, just to see what the return value ends up as. Just because we've got a lot of stuff in there. Right, so we end up at one break, and we can see here we're like pointing at nothing. Well, we kind of don't want to hit the brakes. So it's branch now that I think a bit more clearly. So we don't want to hit this, which means we had jumped from there. We printed the message, invalid password too long. So where do we, gosh, where do we print that from? Um, I don't know where it does it. Maybe it's like at this point. So we do a string copy and then we do add like a bunch of things. I don't need these two. I probably don't even need that. Right, so we'll do E8. Actually, no, now that I think a bit more about it, we will not do E8. Then we'll do FF for the other one. Right, so we got to this point. I think I don't want this. And we can skip to there. Right, so we get to this bit here, and I think this is potentially where things go differently. Right, so this will jump back if we're not 0. And what are we? We are not 0. So I think this means we're jumping back. So we ended up there. Yeah. So here it's just going to count the length of the string, I guess. Huh. Right, so it's counted the length of the string. Surely it's not that much. No, that's just going to be R4 was the stack pointer originally. Yeah, stack pointer added 4. And we set some tokens in it. I got that here in the nose feeling. Apologies. Apologies. Right, so what do we do now? Where is this looking anyway? 43 CE. 43 CE is somewhere here. We can change that. So F would be this, and right. So this is just after we've counted the thing. Yes, yeah. So this should just be the end of the string pointer, not the length. But now I guess we're 43B5 is likely to start. B5. Yeah, we got an FF there. Right, so now we should get the difference into R11. So we have 25. We do have quite a long string. I think we're what does X do? This one do again? Have to go to this. Is it this? I think this tells me everything. SXT. No. SXT. No. SXT does like some bit twiddling. What is the thing? MSP 430. MSP 430. do I trust this? Uh, it just swaps the things. Is that what I'm saying? Sign extend. Yeah, sign extend makes sense. Right, so we move something from R4, and R4, where are you pointing? R4 is 43cc. 43cc. We have control of it somewhere in there. But we can see what comes out of this R15. R15 is the 12. So this one here. Which is right. Ah, so I see. I kind of want to know which 12 it is. Because one string is getting overridden by another. So we've got the 4-4 start here for the username, and it doesn't go past 12, but then the FF goes up to there. So I guess, well, we can see R4 minus 18, 43cc. F, E, D, C. So here minus what a minus 18. So 16 would be up one. Which we can see by the letter thing. So 18 would be two more over, but then that's a 5. So I don't know how that math worked out. We'll just have to do some testing. But yeah, when we sign extend 15, we still get 12. If we compare that to R11, which was our length, potentially I might need to write some things down. This one is like on the cusp of whether I can keep it in my head. But yeah, when we compare these two things, we get a carry because R15 is less than our length. So I wonder if we reset this, I have like a small suspicion. We'll change this 12 to be 44. We'll just call it 44. We could check what it was actually after, to be honest. Anything that's bigger than 19 is fine for the both. And so this 12 we can change to FF, and we can see what happens there. That will be negative. Can we change that? Yeah, so we get here. We maybe I want to do it on this point here. No, that point is also all right. So I kind of want that point maybe. Yeah, so this will get our length, so 0x19, and then this will get something into that. And so 44 was the username, yeah. So side extend that, doesn't do anything. We compare it with R11, which is our length. This is like a really weird way to say like it's too long. Like I don't actually understand what they're trying to do. But we'll do that. We shouldn't have the carry flag. We've got the N flag, which negative, I guess. If we, that means we should jump. Cool. So we have successfully gone past that nightmare. It's quite a weird thing to have, but yeah, 11th byte. I should change this 11th byte to just something high. Well, it took the usernames one. So it was like right there. Potentially this. Yeah, I don't know. One of them I'll need to change to something else, maybe to differentiate, but the rest, yeah, it's kind of hard to know. Right, so we're at this point here. So now we're getting another number. So we're getting another 11, which I guess means we. Right. So we just got the 12. Did we change the 12 and not the 11? I don't know. One can be 44, one can be 55. We can just change them out of order a little. So we do that, we compare that, and R11 is still just our length. So if those 2 bytes are so it has to be within the range of those 2 bytes. So 11 just stays how it is. That's all right. Otherwise, it does a bunch of things. 7D, what was 7D? We can see in this manual, I think it was. And you'll get like a bunch of things, but interrupt 7D was it? 7D it was. Right, so that's just checking if the password is right. And then it will change some memory. Alright, this seems. Yeah. We also get this thing here. Read of minus 0x2c R4. I don't think R4 changes before then. I can't do that format, but can I do R4 0x2c? Do I want P for this? No, like. I just want to know what that number is minus that number. Read 430x 0x43cc minus 0x2c. All right, does that mean I can just take that? I don't know. Right, so that must be that point there that it will be testing. We don't really need that. Oh, maybe we do, just to see what part of memory was it doing. 3A2, 3A2 will be this FF, which will be the start of my start of the username was that one. So if we go through that, it'll be wrong. So the start of the username didn't change at all. Right, so at this point here we are 0, so we are jumping to like there. So we can also do this branch here. We just really don't care about the branches. So maybe I'll don't really care about that or that. I mean, we'll never get it, I guess. Or potentially we would. Like, can we coerce it into that shape? It's like kind of just before. Yeah, it's before either of the two start. So no, not really. Right, so what's happening here at once? R4 minus 6. So maybe if we get this R4 minus 6, what's that have? That's got the 1 1 just before the start of. That's the 11 in the thing. So we've got our big thing. Our 55 was the max and the. Oh no, so one needed to be less than the length of the string, and one needed to be more than the string. So we had something like that. But then this 11 here is getting tested whether it is 0 as the first one. No, it's the second one. Yeah, so the length of the second string has to be 0. Has to be 0 at this point. Is this what I'm getting? Yeah. So I think what I want to do is I can trim some stuff off. We can have something like this for the first one, and then the second one we can just have nothing even. So, because I think what will happen here is we will go into the password too long, so we don't really need a long password. We can get by with a slightly long username, so we can have it that long, and then our password we can have is just nothing. Are we allowed that? All right. We'll just have it as nothing. Oh, we have a little D at the end. That's our 44. I get it. Right, so at this point, we've hit so we've hit a branch to that. That's not what I wanted. Password too short. Right, so we need at least how much of a password. I thought that did this need to be 55, like a bit more than the other one. And then the password can just be 0. It said password too short, so yeah. This is saying, well, compare that 55 against that, which is 0. This is kind of annoying. Yeah. So the password needs to be of a certain length, but then we have to have that byte of the password. Well, we don't need to be super long. We can. Well, this is comparing it with the 55. Just the first one. This is tricky. Yeah, 10 twice. I think I'll do that. And if we do something like, well, we can have 0 for this as well. Where do we end up here? Right, so here we're comparing 15 to 0. And yeah, we're still just, so we need to be. So that was 10. It did take that. Cool. So what I think I want to do is reset and we can set this to 01 and we'll have a length 1 string. This 01, cool. And then when we come here, we can just have a length 1 string. So this can just be 41. And then we get here. So here it should be, maybe we have to. Nah, cool. So that's cool. Got past that stage. Then we get to this point. This won't. Well, this might at some point, but for now we will do this. So if we are 0, we jump a bunch, and I think that's to the red. Well, it's to where the stack pointer ends up, which if we look at the stack pointer, it ends up looking at that, and like none of my data is around. So I think where it is we want to coerce this into something. So maybe if I'll reset this and continue and get rid of that one. And yeah, this was what we wanted. Yeah. And we just do that. So if we continue, so we should get to this point here. We don't really need that anymore. I am more interested in this. So what is at 43cc minus 2c. This currently has nothing, and it is before the stack. I've already thought this, and I've already said this. I now remember saying it. That is not great. So I'm just wondering how we get to this point, but we have a decent here we can do this. That will probably make it jarring. Um hmm 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 So what did each of the things mean? Because I had a so the 44 was the like max length of it. We could try and trim that down, or I guess this means we can have like heaps longer. So maybe I just want to have it again and see what happens. Um, and the password, oh yeah, that I can just copy paste it again. And there, the password we want to keep small because we want the lengthy flight to be 0 in that case. But in the username, we can just send it twice and see what happens. And password, we can just have the one character. And here, where do we end up? Right, so here we can maybe try read this thing here. And yeah, so no, like how, what am I wanting to do at the moment? Am I wanting to, oh gosh, that one failed. Minus 6, that was over 1. And what do we have? We had 1. Huh. Oh no, I want, because it's overridden because they lay it out like that. Huh, I wonder if I can. Oh, I can do something interesting. So we can have this one. Is that what I want? Because it copies over top of each other. It does like a string copy of like all of it. Yeah, I wonder if, say, I do that again. So getting 3 times. This isn't the place to do it though. This is so we'll do it. Yeah, but that one will be 0, and then we'll just do it again. So we've done it 3 times, and we'll do our one like password real secure. And if we have a look in the uh, get to here, R15 is big. What's R15 meant to be at this point? No, this is just when we've tested that. So I think we can't control this, right? To see to see. Yeah, I just don't think we can control that. So just where we're pointing, yeah, that's just where we're pointing. So it's testing the current stack point. I wonder. Right, so this won't. And the minus 6 was at 0. It doesn't seem like anything we control as well. Though what's minus 8 looking like? Oh no, it might be. So we just end at the there, and so we haven't copied the stuff after that we did try, but then maybe this is. No, we don't have a 4044, but that is probably just after main. Yeah, 4040 is. That's that. So I know what needs doing. So the first one, we can just have a min length of that. That's fine. And if we just do this again, this will be overriding so I don't know. Seeing where we are, this is what we want. So we have got to go this much and then this much. And I haven't put a 0 in this time, so I've just done it 3 times. And try it again. So I'll just try it 3 times, and for the password, I will actually have a longish password. I will just have the 11th bit not set. And so now it should hopefully have. Right, so R15 is like real big, but this one surely will never get. Yeah, so I think that will just never happen. This one, minus 6. So this is 0, but it looks like we control a lot of stuff after. So we're looking at, gosh, it'll be like this one. Yeah. So we're looking at this point in memory, and you can see I've kind of written that third bit there. And I suppose I should have counted to see where we kind of end up. But I guess what I might do is copy all 3 into my current kind of thinking. Basically, I copy it into my paste buffer. And if we continue from here, we should get to a rect, and we can see what SP is pointing at the moment. It's pointing at the 4-5 in the last one. So what we can do is get this 0405 and find what it had like a success, didn't it? Yeah, unlocked door. So there'll be 4A44, 4A44, and that means the rest of this craft doesn't really need to be here, and we can have something this long, but we'll need a. So we'll have something this long for our username. And then we'll overwrite our username with something else that ends there. And that will basically put the terminating null byte in the place that we want, but we have already pre-overridden stuff. So it's kind of an interesting one. So I think when we do that, that was what we want. And so for A, so if we step into that, we go into unlock door. Perfect. So if we solve, we run that as our full input. Yeah, that's the one. And then we need something that is most of that's gone. Just that. And then we unlock it. Cool. That was cool. Wasn't it cool? I reckon I might go to Jakarta. Maybe see what it does. So, right, more stuff to make sure too long passwords don't work. So what do? We do similar things, and we do like a clearing of that. This hopefully will never get called. It will in a normal case, but what I want is to overwrite it to go to this pretty much. So in here, what happens? We do a get thing. We check. We get the length, all right, and then we subtract. No, we get the end pointer. Yeah, so end pointer is R11. We subtract a bunch from it, and it would have started at that. So this kind of gets us a length as that. And then we do a string copy from that, but it's like, oh no, we do a increment first, yeah. And when we do the get, yeah, so we're getting it from there. So we get the length, in essence, in R11. I think that was the same as last time. Right, so we want to compare R11 with 21. So we have a max length on our first string. Yeah, max length on our username is 11. So no, not 11. It's reading from R11. Max length of, where are we looking? 21. So when we hit this will be the 20s, right? No, this will be the 20s when we hit the second lot of things. So we have to have it this long, is what I'm saying. And that's in essence the stuff I wanted to overwrite. So let's have a little look on. So yeah, maybe I'll do a little test there. So I think at the moment it will be slightly too long. So we can try have a run. And see where we are. So this is checking that, and yeah, we're like to C, and it's checking to 1. And so this will set a carry, and we want to jump if not carry. Yeah, so we want not a carry there. So we want, actually, we just want, yeah, we want it to be shorter. So if we reset it and do that, and what was it, 11? We cut out that and redo it. We can check what it is. Now it's checking 24. So I'll still need like a touch more. Yeah. There's 3 more bytes. 1, 2, 3. Here we can see we're 21 on the dot, which I think it does give you a carry. So we will need 1 more byte. So if we did this, just want to check. So here we are 1 byte less, perfect. So that means we're allowed to do our password. So maybe this one is we're overflowing the password, though I haven't checked to see what it's doing. So what do? We get R14. What's R14 look like? It's just pointing to a chunk of memory. 2422. It's pointing to a bunch of memory that is nums and stuff. All right. Is that because it's just at the end of my data? Yes, I end with an OC. So now we're going to put our password at just the point after it. Is that right? I think I need to step through this. So we ask for, well, we asked for the password. We haven't actually asked though. So R14, we set it to that. So the length of the username minus that, is that right? Yeah, length of the username minus 1f, which we have kind of underflowed an integer, I think. Well, we've kind of underflowed. But then they do a mask to make sure that it's not set. That's cool. So R14 is still quite high. Here we get a serial name. So maybe I'll do a similarly long string, but maybe start with 22. Because 22s are tasting like these. So here we're getting the 2402. So that is where we just put our data. We put it out. Are we doing like echo passwording? Yeah, we just echo password. Cool. And here we want to right, so here we want to get the current stack pointer. Is the stack pointer where we've currently controlled data? Yeah, it is currently where we've controlled data. I think we haven't quite overflown it yet, but we're going to add a bunch of stuff to we're going to add the length of what we currently have. So in essence, we're going to get a pointer to this location here. Is what my reckons are. So 4012 would point to this pointer here. Now it's going to copy our string that we did have. So I think I kind of want to, well, we're going to overwrite the return address, clobber it up. So this has clobbered it up, and we can see that there we now have a 22 and all of our stuff. but we clobbered too much stuff. We were a bit too greedy. So here we want to kind of get to the start of our current string. We get the so everything all up has to be less than that, is my reckons. So yeah, maybe if we continue to here, so 20 is the length of the username, and then 20 is also the length of our password. We only had to write a couple of bytes, but the problem is that we're now comparing it with 21, and if both of them are bigger than 21, we have an error. So like, I guess that means like both had a max of 16. It may username may not together may be no longer than 32 characters. They're quite strict about it. That's interesting. Yeah, I kind of wonder what can be done there. I wonder if in this debugger you can like change the memory. Oh, that doesn't feel good. Yeah, you can change the memory. So I could change this momentarily. Let R15 equal something a bit less. So maybe we can make it equal to 20 just for this. And that way we can we've already done it. Yeah. But I can let PC equal well, we can just do the 4604 again. Do that check again. Actually, 46. Gotta do that, and then we can compare this. We shouldn't have to carry. No, R15 is like massive. What if we go here, but let R15 just be that? Now we should kind of jump over. So what happens here? This does the 7D, which is the HSM. Yeah, so we can't really do too much there. But yeah, I guess if we continued out of here, I didn't have a thing on the rec. We can see kind of where we ended up. I'm not sure if that kind of showed it. 2383. Yeah, we must have just done some things. So if we have a long one. And then, yeah, so you're good. But then we maybe only want to do that many. But I think even that's too much. Yeah, so now it's too much. Where's my where's my let R 15 equal 21? Actually, 20. So what would have happened would be we would have stack pointer at this or for so that would be just after the data that I did right. But it does kind of mean that we can't really get there. How do we do this? So the first string gets gotten. And then the R15 is just a little type loop checking for null bytes. So then we have R11 is our pointer to end of string. We subtract the start of string. So R11 should be the length of the first string. Then we get R14, we copy it to our stack pointer. Yeah, so we copy it to the stack pointer and make sure it isn't. Otherwise, we should now. Yeah, so this bit here I didn't really get. So we are getting R14, which is our stack, is it not? Is that what we put in stack? No. It's like if there. And just one if there. But this is the length. Right, so yeah, that's a bit silly. The order is like different to the assembly order that I usually am used to. Right, so we're subtracting the length from R14. From 1s. So this does some overflowing. I do recall this. So where are we at the moment? We'll do something like that and do something like that. Yeah, so before we ask for that, we do some overflowing, and this is getting. Does get SN make use of R14? Like, why is it? Because it's getting overridden again here. I wonder if get SN it pushes R14. So 2 for this. A maximum number of bytes to read. So we are saying how many bytes that we're going to allow to read. Does that help? because we can say it's a really big number. How do we get SN the first time? Get SN is normally just FF. So it still asks for like quite a big number. Right, and then this is, it will do the overwrite, but then do the test, but then the test will just stop. And that's the good part, which I want. Right. Ha. I wonder. What I wonder is, gosh, it'll be tricky. Oh no, like then like this check would fail. Like I feel like each of the string lengths having to be less than 21 is fairly set in stone. And like this might be a red herring because we'll do the copy, but then we'll do the length check. Subtracted from that. Yeah. Yes. So, my thoughts. And I'm fairly certain that it's not in like another random place. Because we can't really control anything like that. We have to get out the function somehow. And this thing here, like all it does is really does this interrupt. And like I think that's fine because it's adding a byte to the stack pointer and it's decrementing a byte up here. So I don't think we can really control the stack on this. But we can on this, but we have to just make sure that we don't get to a path where it says it's too much. So I wonder if so this is like a weird one where we have this was a different one, I think, but I mean that's kind of handy to stick around. We have length minus 1f, and the max of the length max is 0 to have more than that, you'll set the carry bit in the compare up the top here. So here we've got this, and it will get length minus that, which no, it's getting negative that minus the length, and this all, and 1FF. So it's kind of assuming that it is going to go negative, I think, because you kind of have to hit the very sweet spot in the middle where so if length is 0x20, then 0x1 minus length would end up being 0x like e, something like that, because it will be like -1 in essence. And this would get kind of trimmed down to like 1FE. Am I correct? Yeah, there. Am I correct in the will you do this? You can't do that. My twos complicating, I think, is correct. I mean, we can do it with a little test dot nothing. Test dot C would do it. In fact, we can do load main and maybe do a printf. X. In fact, I wonder if it just built in the printf with the percent %x there, and if we did -1. Yeah, so it was F. So it would be that if it was 0x20. So if we had 1F for our length, so if we had slightly less, then this would just end up being 0. If we had 1E, no, losing the keyboard. 1E, I should plug that thing back in. So this would end up with 1. So it kind of ends in a range from there up to, I guess the lowest length we could have is 0, which would give us 1 here. So it's kind of an interesting range. And this is just kind of passed straight into get serial number, which is then just used to push it onto the thing for int 2. And then 2, 4, 6, that would basically, in essence, pop off all those. Is that what that is? Yeah, I also wonder do that. Let's see, what are we? I think I might need to finish up here without solving it, almost. Because yeah, this is just a big loop as well. To get SN, yeah, I think I can't do too much. Do nothing. Because I'll just get. Then we'll do a string copy. And then check the length. But the first one will not be the right length. So I'm wondering if we almost limit the length that we pass to get SN, whether that will change the way things look in memory. And we could do this, do one chess, we can do this by taking off one byte, really. And so this should be fine. And here we'll R14 is just 0 now. So I wonder what get SN does with 0. Like if we do do something like that, does it actually it doesn't look like it's read any stuff, because why should it? Or is it up there? Yeah, so it kind of starts with a null byte now, though, because it's overwritten before it was probably a bigger number, whatever at the start of this is FF. So it will hopefully echo our password back out to us. And here, I will copy that onto the stack plus wherever we were, which isn't really that helpful. Nah, I'm not sure like quite what to do here. This is just a loop, and here we add the two links together, and we're not too big, so we would just kind of continue buttering along. And when we're wrecked, we're miles away from what we control. Like we're still a number of bytes away. I'm not too sure. Yeah, let me get here. I know why it does this, but I think that's that. I'll leave it. Didn't quite get there. Got to. But yeah, we'll come back to this another day. For now, I've got a movie to go watch and see things like that. Enjoy and have fun wherever you are, and I'll see you next time.